Let's consider 4 types of IP communication flows. First up is unicast. Unicast is one-to-one communication. We're going from one IP address directly to another IP address. If you consider the example on screen, we've got a video server and it's going to be sending out a video stream the goal is to send it out to some but not all of the corporate clients. Let's say that PCs 1 and 2, they want to get the video stream. PC 3 does not. Well, with unicast, the video server would send one packet to PC 1 and it would send a duplicate packet to PC 2. That's not terribly efficient. Now, unicast, that's our main form of communication. It's just not a great fit for this scenario. Another option besides one-to-one communication is one-to-all communication, and that's a broadcast. A broadcast is sent one time, and it goes to everybody within the local subnet. So the video server sends out the packet, and it goes to everybody in the subnet, including PC3. So I would argue that the best fit for this scenario would be to use multicast. Multicast is one-to-many, and the many, that refers to members of a multicast group. You see, the video server can still just send a single copy of a packet, and it can go to all members of a multicast group. Now, a multicast group in an IPv4 network, it's going to have a Class D IP address. That means that the first octet is going to be in the range of 224 through 239. With IPv6, if it's a multicast group, it's going to begin with an FF. But here we have an IPv4 network. And notice what happens. The video server sends one packet, one time, and it goes to all members of that group. That's a lot more efficient. Now, technically, IPv6 doesn't have a broadcast, even though it does have an all nodes multicast. I think that's almost cheating to say that it doesn't have a broadcast, but it doesn't have a broadcast, but it does have something IPv4 does not have. It has something called an anycast. So unicast, one-to-one. Broadcast, one-to-all. Multicast, one-to-many. And anycast is one-to-nearest. Let's say that we've got some sort of content distribution network where we've got video sources or data sources that are duplicated around the globe, and we want to send our clients to the nearest source. Well, we could use anycast to do that. With anycast, we go to a destination IPv6 address, and that address lives in more than one location. How do we know which way to go to get to it? Well, that gets into a BGP configuration that our ISPs can handle. But we're going to go to the nearest source that has that particular IP address. And maybe in this case, server 2 is physically closer to us than server 1, and that'll be the destination we select. So unicast, one-to-one communication. Broadcast, one-to-all. Multicast, one-to-many. And anycast, one-to-nearest.